Hey guys, someone wanted me to go over default gateways and what they are, why we use them, and how to identify slash configure them. So I'm on the second Netacad course, Routing and Switching Essentials, and I'm on slide 1.1.2.2, and it just has a picture of two PCs. You see PC1, PC2, you see a switch, and you see three little routers that represent the internet. Then you have a switch and you have a web server. So a web server is nothing but a server that's dedicated to host a website. So just like you go to google.com, there's a server somewhere in the world that has that page on there. You go to the address and it downloads to your computer. That's all, right? We can just ignore the FTP server. Don't worry about it. But how do we identify what the default gateway is? And a good method is to always look for the closest router. Look for your exit, right? And that would be this router. There's no way for me to get anywhere on this side without going through this first router. So that has to be my default gateway. Or you can look at it reverse. You can take your router and you can say, hey, my IP address for this port is 192.168.1.1, and anything connected to that port needs to talk to me to do it. They need to go to 192.168.1.1, and that is the default gateway. So that's the same for this FTP server. That's the same for PC2 and PC1. There's no limit on default gateways. You can't run out of default gateways. You can't, you know, I'm not going to say you can't overuse your default gateway. You can, but um, that's something else. That's just like congestion. But just take note that everything shares the same IP default gateway, or that same IP address, which is this port right here. And over here, the 172.16.1.1 is the default gateway for the web server. So the web server always sends the message here to get to you, and you always send your message here to get to him. Right? So I have a lab drawn up, and I'm going to switch it back to real time. And let's see what is going on here. Okay, here we go. So this is my network, right? And this is how the topologies may look while you're taking the Netacad course. I have the 192.168.1.0 network here, slash 24, right? So remember, there's 8 host bits. So that means I get 254 addresses, valid IP addresses, right? Because 2 to the power of 8 is 256, and we have to subtract 1 for this address, this dot 0, because it is the network, and also the broadcast, which would be 255, right? So our range is going to be 1 to 254. And I can configure those, any one of those numbers on this PC besides dot 1, because I already allocated it here. And that's one of the best practices. Either use the first address for your gateway or the last address. It doesn't matter what you do as long as you're putting it on the PCs the correct way. So as we can see here, my default gateway is 192.168.1.1. My IP address is 1.2, and my subnet mask is a slash 24 or 255.255.255.0. So I will be using simulation mode to show you, right? So what I'm going to do is I'm going to ping this PC, right? And you see this packet. Don't worry about this. This is called ARP, and this is something that you'll learn later. And it's a way to get the MAC address, because remember, layer 2 is MAC addresses, right? And that's where switches operate. And layer 3 is IP addresses, and that's where routers operate, right? And they go hand in hand, like you have to have both. So I can use MAC addresses to talk between these PCs, but for right now, I only have IP addresses. I know this IP address is 1.2 and this address is 1.4. So if I send something to 1.4, my PC is going to say, hey, he's on the same network. I need to use my MAC address. Or I need to use his MAC address, but you don't have it. So your switch is going to send out all those packets to find the MAC address. So bam, you see the packet went from this PC to the switch, and the switch said, hey, he's on the same network and he's out of this port right here, which should be Fast Ethernet 04. So I'm going to send it directly to him, and that PC says, okay, I received it, and he sends it back. Right? And you get the little check mark saying that it was received. So let's send another packet, but across, right? Or actually, let's go back. Let's look at this actual packet, right? So the layer 3, remember layer 3 is where the IP addresses reside. So the source IP 1.2, which is here, that's the PC we're sending, that's why you see source IP, and then destination IP is 2.2, and that's the PC we're pinging over. Okay, alrighty, yeah, just do whatever you want. Alright, okay, so that's the PC over here, 2.2. Right, and notice the gateway is on the same network. That is a common mistake when you're first starting off, is the default gateway doesn't match the network of the IP address. If these aren't the same, it's not going to work. It's not, right? So make sure your IP address falls into the range, or your default gateway falls in the range of the IP address. And it shouldn't be a problem as long as you put a valid host IP in the same network on your router, right? And that's what I have the colors here for. The blue represents this network, the purple represents this network, and the yellow represents this network. So I know that all these links in here have to be a part of this network. All the links here, these two right here, they have to be a part of this network, and all the purple links here have to be a part of this network. So again, take note that 1.2, oh wait, this went back. Here, let me just delete that and then start a new one. So 1.2 from here going to, okay, well, I figured out what I did last time. I'll just avoid that. Right, so 1.2 is here, 2.2 is here, right? But when you do the ANDing, if you do it on paper right now, or if the computer does it, he's going to identify that the IP address isn't on the same network. So he knows he has to send it to the router, right? But what happens is he doesn't send it directly to the router using an IP address. Oh my goodness, where did it go? Okay, I can't. All right, he's not going to send it directly to the router with the router's IP address. He's going to use the MAC address. because the layer 3 has to keep this, the IP address of PC3, right? And I like to imagine it as an envelope, right? There's 7 layers, 7 envelopes, right? So 7 gets put into an envelope, and then that envelope that contains 7 gets put into an envelope that has information for 6, and then that envelope gets put into another envelope for 5, and then to another envelope, right? So the switch, think of it as the switch only has the clearance to look at layer 2. He's not allowed to look at layer 3, right? But the router, he's allowed to look at layer 3, and what happens is he rips up this envelope and puts a new envelope with a new address. Oops, see, I avoided it right there. So right now, the layer 2 MAC address is this. If we look over to G00, right, and we go all the way to the right where it says MAC address 0002.1758.2601, that matches the layer 2 address right here. Right here. Because that's where it's going. And you read it, Ethernet header, right? Coming from, this is the source, 000A, 410B, 478B, which would be the PC, right? And it's going to 002.1758.2601. So you can see that the IP address is destined to this PC, but the MAC address is destined to the router. And that is how we get to the default gateway. And we'll see it in real time right now. See, this packet is going to go to the switch. The switch knows the MAC address of the router, so it's going to send it up, right? And then let's click on the packet right here. So I'll teach you how to read this from Packet Tracer. So this is the OSI model. So that layer 1 through 7, and then 7 through 1. In means that the packet is coming in, and then out is what it's being changed to when it leaves. So here we can see layer 1. That's the first layer when something is going in, right? So it comes in on port G00, which is this one, so that's correct. It has a MAC address source of PC1, which is 478B, or PC0, sorry, and it's directed to 0002.1758.2601, and we verified that that is the MAC address of this interface, right? So remember that each network interface card has its own MAC address. So your PC has one, right? Typically, it can have multiple. It can have one for wireless. It can have one for tunnels, for virtual ones. It can have one for the Ethernet port that you plug in. Each port has its own MAC address. So that means that this router has one MAC address on this port and one MAC address on this port. So you should remember that. So we come up here to the layer 3 IP. Notice how the IP address isn't changing when it comes across, right? When it comes out, it's still going to be 1.2 as the source going to 2.2, right? And ignore the ICMP message type that's above right now. You don't have to worry about that. But notice that the MAC address changed, right? So 2601 was the 2601 was the MAC address for G00, which is this local port for this network, for the 192 network, but 2602 is going to be the MAC address for this port right here on the yellow network. So the router changes layer 2, and he has that power. He rips up the envelope and he says, all right, I got the message, so now I need to forward it to the next person. But the next person isn't going to have the same address as me. So what he does is he already communicated with this other router right here, and he has the MAC address of this, which is 00E0F9BA8202. And we can verify that. There we go. So G00, oh, actually it's G01 because we're sending it to the 10.1.1.2 network. 00E0F9BA8202. So there you go again. So when you're sending these packets across networks, the layer 3 information has to stay the same. If you change the layer 3 information, the packet will never get to the destination. Never, ever. Right? So that's why we keep layer 3 information the same, and we send messages by using the MAC address. Because each device knows the MAC addresses of everyone on their network as long as there has been communication going on. Right? If there's no communication, then they have to learn MAC addresses, and that's when ARP comes in. But again, you'll learn that later on. So we'll watch this go forward. All right, it comes over to this router, right? And it comes in through port G01. The MAC address goes from 2602, which is here, and I did it again, which is here, and now the new MAC address is, the new destination MAC address is 8202, right? So that's probably this port right here. Or, wait, 2602, yeah. Yeah, exactly, yeah. So that was the in, and now this is the out. So notice the layer 3 still hasn't changed. It went from here to the switch to this router to this router, and that layer 3 has not changed. It can't change, it won't change, because if someone changed this, it wouldn't make it. That's like if you send mail through the post office and then someone at the post office change the address to go to a second post office, and then when that second post office gets it, they're going to be like, well, I don't know what to do with it now. So that's why we have to keep layer 3 information the same, and we use layer 2 because we can rip off this envelope and just put it in a new envelope with a new address. So here is going to leave this interface and go out of gigabit G00, which is right here. Capture forward is going to go to this switch, and the switch, right, the switch can only see layer 2 information, so that's why he's blind. He can't see layer 3, 4, 5, 6, 7, right? Now there's switches that can see more layers, but in this instance, this particular switch can only see layer 2. Right, and we see, again, the Ethernet header is changing. Right, it's changing as going to this PC. We capture forward one more time, and it makes it. Right? So it comes in. This PC has the ability to read layer 3 because he looks at the MAC address and he says, hey, this MAC address is mine, so I'm allowed to read this message. If the MAC address doesn't match, he's supposed to drop it. But since he received it on his port and it had the matching MAC address, he's allowed to rip up this envelope and see the layer 3 information, and he verifies the layer 3 information, and then he rips that up and he gets to see layer 4, and he verifies layer 4, and it keeps on going until he gets to the data, which is layer 7, or depending on which model you're looking at, um, the whole application layer 5, 6, and 7. So then he will, let's see, he will send it back. So he received a message from 1.2 to him, which is 2.2, and now he's going to reply. He's going to say, hey, I am 2.2 now, source IP 2.2, destination is going to be 1.2, and he's just going to send it back, all right? And that's ARP right there. These green packets, that is ARP. And you see, look, like I said before, the message, the ARP packet, is destined to this IP, and it has this MAC address, right? So all Fs are broadcast. And you keep hearing that over and over again, but this message isn't destined because it saw that it was a broadcast, and it checked the IP address, and he said it wasn't me. It's not me, so I can't open it. And that's going to happen for both of these. But this router gets it because the MAC address matches. Oh wait, actually, what? Oh yeah, this is ARP. Yeah, so the here, let's go back one. Let me re-explain that. So what happened is the right the destination IP is 2.1, and that is right here, right? So because this is 2.1 and the MAC address was all Fs, it means send it to everyone, and whoever's IP address is 2.1, they're going to reply to me. So that's why these two didn't reply, because this is 2.3 and this is 2.4. But this one is 2.1, so he will reply, right? And now this PC can update his MAC address table, and he's going to send, he has the MAC address of the router. We can go back there, 8201 G00, right? He has the MAC address of the router again, or now, and he can send it directly to the interface, which is his default gateway, using the MAC address. That's going to go forward. And now the router is going to change that MAC address. You see the difference? It's going to go from 485A and 8201 to 8202 to 2602. So now we're going back to this router, and then it comes down and it goes back home. Right? So that is why we need a default gateway, because we can talk to these people all day with just MAC addresses, and that's fine. But if we need to get out to a different network, say this is your home and this is your PC, you know your brother's PC, your sister's PC, and you're all connecting to your router. Well, you guys can talk to each other all day. You can send each other messages, pings, whatever, back and forth all day. But to get to another house or another network, or to go to Google or Facebook, you have to go to your router. You have to use the MAC address of your default gateway, right? And that's going to forward it over here. And then it's going to come down here, and they're going to reply. And that's pretty much it for the what and the why. So how do we configure a default gateway? It's simple. All you do is look at your network, right? And I know that 8 bits here, 2 to the power of 8, 256, minus 2 is 254, so my range is 1 to 254, and all I have to do is just pick one. It doesn't matter what it is. It's suggested that you do 1 or 254, but you could do 10, 20, 30, 40, 50, whatever you want. And how you do that is you just configure an IP address on that interface. And we do that by doing enable, configure terminal, right? And then we go to the proper interface. So you have to be careful with how you're plugging into your router. There's no set way to how you should plug in your router, but just plan before you start connecting things and write it down, and it saves you a bunch of headache for simple problems. So I'm going to connect this, right, G00, so I know this is G00. Just connect this, G01, so I know that one is G01. And it gives me the little messages, right, the logging messages telling me that these interfaces went down and then they came back up. So, but let's skip past that, please. Okay. And then I type in my interface G00 because I know that is the local interface right here. And all I have to do is type in IP address 192, your IP address that you chose. So I can do 1.1 and 255.255.255.0 because that is a /24, right? And then you do a no shut. I can see my link is already up, but you know, a good habit, you know, make sure your port is up. And that's it. That is it. I can show you what happens if you take away the gateway. If I delete this gateway, or actually let me show you that it works first. That would be a good idea. Right, so that's correct. What I'm going to do is ping 192.168.1, no, .2, because we're trying to get across to the other network, .3. Now, the first ping is gonna fail, but the last three, and that is because of ARP, right? The ARP, the first packet is trying to figure out the MAC address of the router because we haven't used this PC yet. So here, let me see if I can show you that as well, because I want you guys, you know, since it's a video, you guys can just rewind and stuff. But command prompt, let's see if this will work. Right, so no ARP entries found, right? And if you can, look up ARP. It stands for Address Resolution Protocol, and what it does is it just matches the IP address to a MAC address. So ARP, right? So here you can see that this PC has a list. He said, I communicated with 1.1 before, and I've communicated with 1.2 before, and these are their physical addresses. So now I have the physical address of the gateway, which is .1, we know that, and .2 is PC0. So PC2 can talk to him, and it can talk to him. But since we have no ARP entries in PC1, if I try to ping across again, 1.2.2, or let's do 2.4, it doesn't matter. Right, that first one is always going to fail because of ARP. ARP has to find the MAC address of the router, and we go back and we check, right? We go back and check, do the ARP-A 192.168.1.1. That is our IP address for the default gateway, and that is the MAC address. Dynamic just means that it was found dynamically, meaning that you let the computer do it itself. You can do static entries if you want it to. Um, there are certain reasons for that, but generally we just let ARP do it itself. But that's it. Uh, Hopefully you guys have a better understanding, and I look forward to helping you with your next problem.